Okay, Engineering 2 again, the smokestack. Are you ready? This one's a little bit tricky. The main operation here is a revolve. All right, everybody in class, I saw some of you trying to draw circles and lofting and stuff. You can try that, but it's really a revolve. And actually, the top part we make with a hole. All right, so basically, we're going to draw the outside profile of this, revolve it, and then put a hole to get that part right. Um, so here we go. We got to make a new part, file, new. If you get to this screen, just standard.ipt, create, or start a new sketch on that vertical plane. And let's see, we got to kind of go back and forth here. I got to look at the total overall height is 1.75, 1.5, 2.25. All right. So first thing I'm going to do is make a vertical line here, 1.75 inches. I just type it in manually, hit return. Goes up. All right, so I got to get my view correct here. Now I'm just going to draw kind of the rough shape of the smokestack without paying much attention to the dimensions. All right, hit escape on the keyboard. Now I'm going to start dimensioning what I know. Well, I know this line is 0.25. Oops, missed the 2. 0.25. I know up to that middle part is 1.5 and up to the top is 1.75. So I'll dimension that. 1.5 up to that where that kind of that ridge is around the middle of it. 1.5 up to the top. 1.75. Oops. So actually I don't need to dimension that. I already did it. Now we got all the heights right. Now we got to get the radii here, right? And think about the radii going from that center line to these 3 different locations. Now, a couple of them are pretty obvious, but the last one is a little bit tricky. We actually are going to have to do a little special thing here. So the diameter of the bottom is 0.5. The diameter of the middle part is 1.25. It doesn't tell us the diameter of the outer part. This is the diameter of the inner part, this 0.375, of this part right here. This 0.875 is diameter of the top here. This is a counter bore hole. We'll do that in a second. So I have the diameters of the bottom and the middle. I don't for the top. We're going to use the angle to get the top. So the bottom, if the diameter is 0.5, then the radius is half of that. And you can use this like a calculator. I'm just going to do 0.5 divided by 2. Obviously, I know what that is in my head pretty quickly, but why not use the calculator? Now, the diameter of the middle part is 1.25. So dividing that in half is a little bit trickier, right? 1.25, it's a little trickier to divide that in half. So remember, guys, you can use the calculator here. So 1.25 divided by 2, and it gets it right, which you can see it made the top look crazy. So the top's way too big. Now, angle. How do we do that? Well, I'm going to hit escape. I'm going to drag this point in so it gets right, so it gets approximately correct. What I'm going to do, this is important, guys. That 15 degrees, you see that in the drawing? 15 degrees. I'm talking to the in class now. It tells us 15 degrees right there. So reference to a vertical line, the angle of that, it's almost like a chamfer. Don't try doing a chamfer. That's just going to be a headache. The angle of that is 15 degrees. Um, you probably could actually do a chamfer, but it might be a little bit difficult. We'll go back and try that after I show you this. All right, so a line, we're going to make a vertical line right here, but we're going to make it a construction line. So right up here, construction, you click that. So when you draw your line, what it's going to do is, you guys see that yellow dash line? So that's a more advanced thing that we're going to do this year. This is in class, guys. That's a more advanced thing we're going to do this year is using construction lines for references. So I made that by clicking this red button here, construction. And that makes it so it's not a solid line. You can't use it to extrude or anything, but you can use it as a reference. And now when I dimension, I click dimension, I click these two lines. I click this line, the actual object line, and the construction line. Note my cursor, before I even click, my cursor changes to like an angle. That's what we want. So we make that 15 degrees. And that'll be correct, and we'll revolve that now. So finish sketch, and we'll revolve it. That's the shape. The axis is going to be that vertical axis. Okay. I'm going to start another sketch on top really quick. I'm going to put a point in the middle. Finish sketch. I'm going to make a hole. It's going to be a counter bore. Now, it's going to be a simple hole. So the last hole I made was a threaded hole. It saved those settings. So I want it to be a simple hole. And you're going to look back at here and see what the stats are. So the top diameter is 0.875 at a depth of 0.375. All right, so that's these numbers here. This is 0.875 and 0.375 depth. All right, and then I got to go back to my PDF. The bottom's diameter is 0.375, and it's going to go down to the bottom here, which we'll have to figure that out in a second there. So this diameter is 0.375. Now we don't want it to be through, right? We only want it to go down to the very bottom here. So we have to do a distance. Let's see, can we do 2? Yeah, we can do 2. And then I can make it go down to that, and that's not working. All right, we'll make it a distance. We want a flat point, and we got to go back and figure out what that distance is. So the total from here to here, total is 1.75. We need to be 0.25. The distance from the top to the bottom of the hole will be 1.5. So that's this measurement, 1.5. Okay. All right. That'll be it. There's our smokestack. All done. Now, one thing I just want to quick see here in this revolve is if a chamfer would work. So I'm going to kill that angle that we put in. I'm going to kill that construction line. I'm going to make this just straight up and down. All right? So it's just vertical. Now, if I do a chamfer, yeah, that's not going to work because it wants a distance and an angle. It wants a distance this way and then an angle. So 15 degrees, the distance is the top distance, which we don't want. Let's see. And I can go, maybe if I click this side, it'll work that way. Yeah, actually that did work because 0.25 is the distance of the surface you click, and then the angle goes back from that. If I click the top surface first, it wouldn't have worked. You have to click the side surface, and you hit apply. That does work. So so that distance measurement here has to be the distance of the surface that you want to chamfer back. So that works. All right, thank you.